Stephen Hawking, The Illustrated A Brief History of Time / The Universe in a Nutshell. Embark on an enlightening journey through space and time, as renowned physicist Stephen Hawking demystifies some of the most puzzling elements of our universe. In his iconic book, The Illustrated A Brief History of Time / The Universe in a Nutshell, Hawking walks us through revolutionary ideas of notable thinkers including Aristotle, Copernicus, Newton, and Einstein. By exploring theories like general relativity, quantum mechanics, the Big Bang, and the enigmatic phenomena of black holes, we inch closer to understanding the fabric of the cosmos. Though often overwhelming, this comprehensive summary will unveil the transformation of human thought and progress in our quest to comprehend the universe's secrets.
The Ever-Changing Universe. A lecture on the nature of the universe sparks a debate on its actual structure, leading to the realization that our understanding of the universe is constantly evolving. The desire for a complete description of the universe and its origin has been the motivation for the development of theories that have been changing through time. Although opinions may differ, the fact remains that the universe is never the same, and it will continue to be a subject of contemplation and inquiry. The evolution of scientific thought. In ancient times, Aristotle believed the earth was round and fixed in the cosmos, with other heavenly bodies orbiting it. 1,800 years later, Copernicus proposed the sun was the center of our universe, and Newton's Principia became the most important source in physical sciences. Newton's book presented the motion of objects through space, as well as the mathematical tools needed to analyze these movements, establishing the idea of universal gravitation. Scientific thought evolved into believing in a universe with no beginning or end, leading to discoveries in modern space exploration. The expanding universe. In 1929, Edwin Hubble discovered that distant galaxies are moving rapidly away, indicating the universe's expansion and the possibility of the Big Bang. This discovery replaced the old notion of a static universe with a dynamic, expanding one that may have started and could end in the future. Today, scientists use two incomplete theories to describe the universe: the general theory of relativity for large-scale structure and gravity and quantum mechanics for microscopic phenomena. However, as these two theories are inconsistent with each other, scientists aim to create a new theory that will encompass both, known as the quantum theory of gravity. The evolution of physics. Over time, physics has evolved, with Aristotle's belief that objects move only if something made it move being changed by Galileo Galilei and Newton. Newton's first law states that an object in motion will continue its motion unless acted upon by an external force. Additionally, Newton's second law shows that the rate at which a body changes its speed is proportional to the applied force. Newton saw the universe without any fixed standard, in contrast to Aristotle who believed in a preferred state of rest. Conversely, Newton found solace in time, which he believed to be an unshakable absolute force. James Clerk Maxwell predicted the existence of electromagnetic waves that contradicted Newton's laws of motion, leading scientists to create a mythical ether to account for the discrepancy. However, Albert Einstein suggested that gravity is not like other forces but rather a consequence of spacetime being curved or warped by the distribution of mass and energy within it. Einstein's theory ended the concept of absolute time, revolutionizing physics. The expanding universe and theories of its origin. The universe is not static but growing rapidly. With each passing billion years, it expands by up to 10%. The concept of singularity is essential when discussing the universe's origin. Physicists Stephen Hawking and Roger Penrose suggested that the universe began as a singularity due to the rate of its expansion. However, later, Hawking changed his mind and denied the existence of the singularity. This idea emerged from Penrose's discoveries about the behavior of collapsing stars, which relates to the universe's workings. Applying Einstein's relativity theory in 1970, Penrose and Hawking concluded that the universe began as a singularity, and this idea became widely accepted. Understanding Heisenberg and the uncertainty principle. This summary explores Heisenberg's uncertainty principle, which revolutionized physicists' understanding of subatomic particles and their behavior. The world of subatomic particles operates according to a fundamental principle of uncertainty. This principle was formulated by German scientist Werner Heisenberg in 1926 and is now known as the Heisenberg uncertainty principle. Heisenberg's theory demonstrated that determining the position and velocity of a subatomic particle poses a challenge since doing so alters the particle's velocity. This realization had a significant impact on scientists' understanding of the subatomic world and forced them to look for better explanations. Quantum mechanics emerged as the new explanation. Unlike traditional mechanics, quantum mechanics proposes that particles do not possess distinct, well-defined positions and velocities. Instead, they have a quantum state that combines both properties. Consequently, quantum mechanics works on the principle that observations yield multiple possible outcomes, with each outcome having a different likelihood of occurring. Heisenberg's theory also explains the relationship between the particle's velocity, mass, and position, as he demonstrated that the uncertainty in the particle's position times the uncertainty in its velocity times its mass is never less than a certain quantity known as Planck's constant. However, the mathematical complexity of quantum mechanics conflicted with Einstein's theory of relativity, which governs the large-scale universe. Einstein never fully accepted the uncertainty principle's randomness, commenting famously that God does not play dice. The disagreement between Einstein and Heisenberg has led scientists worldwide to seek a new theory of relativity that can incorporate the uncertainty principle of quantum mechanics. Understanding Heisenberg's uncertainty principle is crucial to understanding the behavior and nature of subatomic particles. The strange fate of stars. In 1928, Subrahmanyan Chandrasekhar discovered that when a star had burned all its fuel, it would collapse back in on itself due to gravity if it was of sufficient size. This led to the idea of white dwarfs and neutron stars. However, stars bigger than the Chandrasekhar limit can explode or shrink to a singularity, becoming a black hole. Robert Oppenheimer's work on singularities revealed that beyond the event horizon of a black hole, nothing can escape. While they cannot be seen, their effects on other orbital bodies prove their existence. The search for a unifying theory. The possibility of a unified theory in physics has theological implications. While physicists focus on describing the what of the universe, philosophers struggle to keep up with science's technical advancements. The hope is that a unified theory will simplify enough for a broad range of people to grasp and provide an understanding of the very mind of God. Einstein once pondered if God had a choice in constructing the universe, to which a possible answer is that God chose the initial configuration of the universe for reasons we may never comprehend.
As we delve into the heart of the universe's mysteries, one cannot help but be awestruck by the ingenuity and persistence of human imagination. From challenging ancient notions of a static cosmos to recognizing the dynamic, expanding nature of the universe, we are driven to find a bridge between the principles of general relativity and quantum mechanics. This pursuit continues as we seek answers to questions like the very beginning and possible end of the universe, and confront the enigmatic concept of black holes. Though our understanding of the universe is far from complete, the relentless pursuit of knowledge and a unified theory, and perhaps even the mind of God, is a testament to the indomitable spirit of human curiosity.